In a daring proclamation, scientists have declared the identification of a completely novel planet, distinct from any previously discovered. NASA, renowned for its groundbreaking investigations, has revealed that this recently detected planet is captivating not only due to its dimensions and location, but also because it radiates a glow that seems unnatural. Could this revolutionary find signify that we are nearing the threshold of unraveling enigmas that could dramatically transform our understanding of the universe? Does this exposure imply the likelihood of existence beyond Earth? As we explore NASA's astonishing findings, we might soon bring to light the reality behind these exceptional illuminations. In 2007, NASA initiated the Dawn probe with an objective to explore some of the most enthralling entities in our solar neighborhood. Fitted with 3 ion thrusters, Dawn began a voyage that started with a 14-month examination of Vesta, the second-largest rock in the belt. Dawn relayed detailed visuals and metrics, unveiling Vesta's intricate terrain and abundant geological legacy. Upon wrapping up its objectives at Vesta, Dawn advanced to what may be considered the most thrilling segment of its expedition, an intensive analysis of the dwarf planet Ceres. Thanks to its ion propulsion, Dawn succeeded in escaping Vesta's gravitational grip and proceeded toward Ceres, something conventional fuel-driven systems could not have managed. These thrusters provided a continuous push, allowing Dawn to traverse immense spans and attain a consistent orbit around Ceres. Spotted in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the most substantial object within the asteroid zone situated between Mars and Jupiter. For decades, it was viewed as the tiniest dwarf planet in our system until its reclassification in 2006. With an approximate diameter of 950 kilometers, Ceres stands as the biggest and heaviest body in the asteroid belt, making it one of the most fascinating due to its unique attributes. Experts impatiently anticipated the inaugural high-resolution visuals of this enigmatic realm, which displayed radiant patches dispersed across its facade, notably within a prominent crater called a crater. These luminous areas instantly sparked immense curiosity within the scientific arena. Before the Dawn endeavor, our best glimpses of Ceres were fuzzy, lower-quality photos captured by the Hubble Space Telescope. There was minimal knowledge about this dwarf planet, and the opportunity to gain detailed visuals promised exhilarating revelations. The mission of Dawn sought to expand our comprehension of how the solar system came into being and the significance of water in crafting planetary entities. The gleaming regions on Ceres, also spotted on other space rocks, were believed to consist of highly shiny materials, perhaps salts deposited from evaporated water. This hint led to the possibility of cryovolcanism on Ceres, an occurrence where eruptions release not molten lava, but liquid water or salty mixtures. What these puzzling illuminations truly are, and what secrets they might disclose about Ceres, remains an unresolved inquiry. Might they be indications of present-day geological action, or do they point to something even more phenomenal? Ceres differs from other asteroid belt inhabitants because of its volume, weight, makeup, and likelihood of harboring water and frost. As opposed to the typical stony asteroids, Ceres has a composition that mirrors that of a comet, suggesting it could contain crucial clues about the infancy of the solar system. After 2 years of transit, the Dawn spacecraft finally neared Ceres in early 2015, marking a pivotal event in its mission. As it prepared to transmit the first close-in images of the belt's largest member, the vessel drew nearer to Ceres, unveiling a world once shrouded in obscurity. Initial snapshots of Ceres depicted a crater-marked surface, pointing to an extensive record of collisions. However, it was the brilliant spots among the dusky, rugged landscape that caught the eyes of researchers and space buffs alike. As the clarity of the photos improved, specialists formed various hypotheses about these spots. Were they ice patches bouncing sunlight, or did they embody something far stranger? Ideas spanned from mineral deposits to potential traces of cryovolcanic action. To everyone's surprise, closer analysis showed that the brightest region wasn't one solid mark, but rather a grouping of several separate luminous areas. The most commonly accepted interpretation was that these were salt accumulations left from evaporated water. This indicated that Ceres might possess, or previously possessed, some geological mechanisms that could raise water or brine to its surface, where it would quickly vanish into space, leaving reflective remnants. These observations appended prior beliefs about Ceres, presenting an updated image of a lively, intricate world. The idea that subterranean water or briny chambers might lie beneath the crust poses captivating inquiries into the prospect of extraterrestrial life. Ceres is often called a frosty world, with a porous yet solid exterior. Unlike many other asteroids, which are mainly made of stone and metal, Ceres is notable for its rare construction. Its top layer contains a mixture of water frost and mineral compounds like clays and carbonates, making it less dense than its rockier peers. This suggests that Ceres holds a large reserve of water. Its rugged terrain is spongy, with ice and other volatile substances ensnared beneath, making it more similar to a comet than a typical space rock. Experts theorize that Ceres possesses a defined internal structure, featuring a slushy outer layer and an ice-enriched core, which constitutes nearly half of its overall mass. This slushy mantle may consist of stone and salty water surrounding a central mass possibly made of heavier material like silicate rock. The existence of vast ice deposits implies that Ceres may have had liquid water in the distant past, especially if its core was warmed by natural radioactive decay. This inner makeup sets Ceres apart from others in its category and spurs fascinating questions regarding its potential for active geology and how water factored into its evolution. Additionally, the detection of ammonia-bearing clays on Ceres implies the dwarf planet could have initially originated in a colder sector of the solar system before drifting inward. Ammonia can lower the freezing mark of water, which might sustain briny fluids on the surface. These findings about Ceres' composition and past expand our insights not only into this intriguing celestial object but also the bigger picture of icy body development across the solar system. Cryovolcanism is a compelling and comparatively rare natural occurrence, especially next to the fiery volcanism we know on Earth. Instead of emitting molten rock, these so-called ice volcanoes spew liquids or gases such as water, ammonia, or methane. These substances can exist in fluid or vapor form in extreme cold, such as the environment found on Ceres. Cryovolcanoes on Ceres function by allowing briny water laced with dissolved minerals to escape to the surface. When exposed to the vacuum of outer space, the fluid swiftly sublimates, transforming directly from solid or liquid into gas, leaving behind glowing, shiny salt deposits. These are the bright patches visible across Ceres. The most notable of these is situated in the Achater crater, especially in an area labeled Spot 5. This zone has attracted much attention for its high brightness and recurring changes noted by Dawn. These variations are thought to stem from water sublimation, pointing to cryovolcanic activity that could still be happening or did not stop long ago on Ceres. Beyond Spot 5, Ceres contains many other bright points, each with its own features. These aren't limited to a single area but are spread around the surface, hinting that cryovolcanism may be common on the planet. The existence of these luminous markings highlights the animated and evolving character of Ceres, countering the belief that it was a dormant or dead world. As Dawn continued gathering high-detail visuals, a diverse range of landforms appeared. The crust of Ceres is littered with impact craters, each narrating a chapter of the dwarf planet's story. Ceres' terrain is speckled with countless impact craters, each serving as a record of the dwarf planet's tumultuous history. These indentations offer researchers valuable insights into the forces that have sculpted not only Ceres but many comparable bodies throughout the solar system. Whether these scars were caused by asteroid strikes or other cosmic encounters, they contribute to the unique personality of Ceres and highlight its role in the grand narrative of solar system formation. Moreover, the discovery of ammonia-rich clays on Ceres provides yet another enthralling clue about its origin. Ammonia is known to depress water's freezing point, which may have enabled liquid water to persist on or near the surface, either in the past or possibly even today. This supports the idea that Ceres may have originated in the solar system's chillier outskirts before shifting inward toward its present orbit. This migratory past could account for many of the peculiar features noted on its surface, such as ammonia traces and signs of icy volcanic activity. As experts persist in examining both the surface and the internal structure of Ceres, their findings continue to reshape our views on how planets take form, the likelihood of life in space, and the internal mechanisms that power geological activity in remote corners of the solar system. Ceres, once dismissed as a mere cold and minor asteroid, has emerged as a mesmerizing celestial body that defies traditional expectations and prompts us to reconsider what might be possible on far-off worlds. The Dawn spacecraft, through its years of dedicated surveillance, has been instrumental in exposing these newfound details about Ceres. The mission, which produced the sharpest images and most precise data ever collected of this dwarf planet, remains a vital piece of our journey to better comprehend the solar system. Each photograph sent back from Dawn revealed further secrets of this dynamic world, painting a portrait of a constantly changing landscape. These revelations mark just the beginning of what is expected to be a continuous inquiry into the mysteries of our solar system's outer regions. In the years ahead, the scientific community will undoubtedly delve deeper into the treasure trove of information gathered by Dawn, searching for additional hints about the potential for life on Ceres and similar bodies orbiting the Sun. As innovation advances and new exploratory missions are launched, even more astonishing findings are bound to surface. Will we detect new indications of icy volcanism or uncover further proof of liquid water beneath Ceres' crust? Time alone will reveal the answers. However, one truth stands clear. The saga of Ceres is far from reaching its conclusion. As NASA's exploration of Ceres progresses, the global scientific community remains captivated by the multitude of breakthroughs emerging. One of the most compelling aspects of this tiny world is its intricate internal design, which may provide essential knowledge about how similar planetary objects came to be across the solar system. Researchers are particularly focused on investigating Ceres' unusual surface formations, which imply that it might still be undergoing transformation despite having existed for billions of years. A key driver of this ongoing evolution is the presence of water in different physical states, which plays an essential function in shaping the planet's landscape. The identification of briny ice and compelling evidence of cryovolcanism sparks fresh possibilities about the geological activity occurring beneath the crust of this dwarf planet. Scientists are studying how icy materials may migrate beneath the surface, potentially generating movements that lead to the creation of new surface formations. Furthermore, understanding the role of salts in this dynamic could provide deeper insights into how similar moons and planetary bodies in the outer reaches of the solar system behave and evolve over extended periods. The exploration of Ceres also opens up exciting opportunities to comprehend the wider phenomena shaping icy celestial bodies. Unlike their rocky counterparts, these frozen entities often display dramatically different properties. By analyzing how geological activity has altered Ceres' exterior, experts can draw comparisons and enhance our understanding of the developmental pathways of other distant moons and dwarf planets. Ceres acts as a live case study of these processes, offering priceless lessons in the science of planetary evolution. As the mission advances, fresh data from the Dawn probe is anticipated to uncover even more insights into Ceres' formation, internal makeup, and geological progression. Every new image and analytical result feeds into a growing comprehension not only of Ceres itself but also of the elemental dynamics influencing the entire solar system. These insights may well redefine how we interpret the early years of our solar system and broaden our sense of what is possible when it comes to locating life far from Earth.